Thank you. Thank you. Well, thank you all for staying. This is Friday afternoon, 5 o'clock. That's hard to do, but thank you very much. So yeah, my name's John. I'm a racker. I'm a hacker. I'm an open stacker, and now I'm a future stacker. That's an awesome thing. That's a really cool thing. So the team at New Relic invited me here to come and share some visionary stuff, and I was trying to figure out what visionary stuff I was going to share, and I looked at the title of the conference, FutureStack, and I said, well, let's talk about the stack. And I know you've got kind of 2 days worth of deep dives on all kinds of different aspects of it. Maybe here today I can maybe bring it all together, and hopefully some of the things that I talk about line up with what you've seen over the last few days. So when we think about the future, I always think about my youth when I went to Epcot Center for the first time. Do you remember Epcot Center? They had this ride, like the Journey to the Future or Future World or something like that. I can't remember the name of it exactly, but I want to take you guys on a journey to the future with the Future Stackorama, right? Future Stack. So we're going to get ready to go on this monorail to the future. But you know, usually when you're on that ride, they don't take you straight to the future. They take you back in time first. So we're going to go there. We're going to go back in time. We're going to see how the stack has evolved over all these years and get some insight maybe into where it's going in the future from that past. They always say that history's a great teacher. So let's look into the past. So most of us don't really have any first-hand knowledge of prehistoric computing. I know you just said they had punch cards, so maybe you have a little prehistoric computing in your background. These things were called mainframes. Back then, it wasn't big data, it was just big computers, right? So they just had very large computers. These dinosaurs back then, they sat behind closed doors. Nobody ever saw them, just a couple of guys then, in the cold room. And they did something called data processing, which I think sounds like a scary term in itself. Today, cave paintings and artifacts, dusty artifacts in museums are all we really have left of these, except for those ones that are still running in some enterprise data centers. That's another story. After mainframes, after we got rid of those, we went on to something called mid-range computers. How many people have ever worked on a mid-range computer? Even know what one is? Name one model number of a mid-range. Like a VAX or an AS400 or a PDP or something like that. Yeah, we had one of those when I was programming Pascal in high school. We had a DEC PDP or something like that. I worked on AS400s in my first job. And it was green screens and token rings. They used to call them broken ring, if you remember that. There was problems all the time with those things. But anyway, that was the short era. That was the dark ages of computing. Then we moved into what I would call the age of enlightenment, where Unix kind of came along. You remember Unix? This is real Unix. This was sort of born out of the mid-range systems. These were what they called open systems. This is when Solaris and Silicon Graphics and the internet was kind of born. I mean, my first internet experience, like Chris said, it was basically on a green screen connected to a Sun Spark station or something like that. So at that time, they started talking about open systems and that idea of a portable operating system interface, if you will, that POSIX compliance. They tried to get there with something where you could move applications around. But these were still proprietary software stacks on top of proprietary hardware, proprietary storage, proprietary everything. So you really, really honestly couldn't move them around. But after Unix, I kept going on that for a few years, and then emerged this client-server area, the industrial revolution, if you will, of computing. You had the emergence of Windows, and you had LANs and Novell NetWare and Dell, and all these companies that sort of emerged as the sort of Henry Fords of computing, right? The early desktop computing pioneers. And in some ways, this was the heyday of the IT department. If you think about your vision in your head of the IT department, what does it look like? Well, it's guys that are running around doing desktop support. It's those guys from the IT crowd on BBC, you guys like that show where it's have you tried rebooting it? So that's kind of the IT picture that I have in my head. So server ops, sysadmins, traditional sort of old school DBAs, all under one roof, all under sort of the IT umbrella. When that all got too big and too complex, the CIO said, let's outsource the whole thing. Let's give it to some big outsourcer. And then a couple years later, they'd bring it all back in. And that's how sort of that IT process kind of happened, how the sausage was made in the IT department. And that's sort of also when what I kind of characterize as big software. You've heard of big oil and big tobacco. This is big software. That was when big software rose to power, is sort of during this era. Microsoft, Oracle, others. I mean, you know who they are. And the IT department, every once in a while, would come to all the devs, all the engineering folks, and say, you must use this stack. You must use the Microsoft.NET stack. You must use Java on top of, I don't know, whatever, J2EE stack, whatever it was, the flavor of the month. But they would mandate this use of a stack, and it was a very well-defined thing. It was documented. It was, drilled into people's head that you couldn't, sort of go off the approved set of even languages were dictated, and that was probably a tough time to be a developer. But then something else happened that I think it sort of represents another era. This is kind of the era of the 90s. You remember these guys? The early 90s, 1993 is when the Power. This is kind of a knockoff the Power Rangers because I think I'd get sued if I used the real ones. But in the 90s, in the early 90s, Linux came to be. I remember in that same college campus where I was playing on the green screens on the Sunbox, I was also downloading like 30 some odd floppies to run Slackware Linux at home. I literally loaded onto tons of floppies and took them home and booted up the first Linux distro on a 386. And that's when sort of Debian and Slackware and all these distros that we've heard of were born. 1993, same year as the Power Rangers. Red Hat came a year later, by the way. And now you have to realize that at this time, you guys, some of you are too young to remember the first days of Linux, but at that time it was really college kids that were using it, researchers, just plain old-fashioned curious geeks that wanted to try something new and try something out. It was clunky in those days, but it did give us an opening, an opportunity to sort of break that stranglehold that big software held. Not only big software, but big hardware, because this ran on commodity servers. And the control, this is a funny picture, I'll tell you what that means in a second. Control was starting to shift from IT to end users, and this is IT trying to hold back the flood of this sort of move from central IT to shadow IT. The IT was leaking out of the business, it was trickling out but really started to sort of go faster and faster. I remember in the early days, I'd hear stories about Linux guys being asked to sort of solve some sort of problem for the business. They'd go home over the weekend, they'd write it all, they'd come back on the Monday morning and say, we've got the solution, but it runs on Linux. And they'd look at him and say, okay, if you want to do it on Linux, we'll give it a try. But that wasn't like the approved CIO, that was kind of the business unit saying, let's do that. But Linux guys were building these solutions. They were building on their favorite platform versus the approved platform. They were building on open source instead of proprietary. They were building on x86 instead of Sun Gear or whatever. And we started to see that real opportunity, that break in the armor. And that also sort of represented the emergence of the LAMP stack. So this is one of my favorite stacks. I love LAMP, right? So and this is an uprising, if you will. So this is when it transitioned from sort of something for the geeks to something that actually was taking hold in the enterprise. We got this LAMP stack, and if you stop for just a second and think about what LAMP stack represented, it was really the first time that you had this opportunity to run a free operating system with a full application stack, with a great database that could really run circles around most of the other platforms that were out there. And LAMP was awesome. LAMP was really good. I mean, I remember Rackspace in the early days, almost every single server was running some form of the LAMP stack. I mean, tens of thousands of machines, pretty much running cookie cutter LAMP stack applications, lots of blogs, lots of portals and web apps and whatnot. And for a while, this was sort of an era that we got really comfortable with, LAMP, and the alternative was obviously Windows and the .NET stack. But for the most part, we thought, okay, now we've got open source. We've kind of arrived. This is the future. But then along came the cloud era. This is maybe late 2000s, early 2010s. I guess that's what we call these, the 2010s. And the cloud was the new thing. It was fresh, and it was this newfound agility, this ability to spin things up and go to market really fast. It was unrivaled in terms of the performance. And now the future has arrived, right? I would say probably not yet. We're still going. We're still going. So think about where we are headed. The future hasn't arrived. Think about what's going on. There's more to come, lots more. There's mobile that we have to account for. We have to think about connected devices. We have to think about wearable technology and smart homes and smart meters and time series data and all kinds of things that are sort of still out there in front of us. And robots. Think about robots. Where's my slide? Click. Okay, there we go. Robots and robots that fly in the sky, right? These aerial vehicles and instrumentation on all kinds of devices and all kinds of things. I saw a quote up here about GE jet engines having 120 some sensors. Well, all that data's got to go somewhere, and it's all got to be stored and analyzed somehow. And even what I'm talking about now is not the next leap forward. The next leap is still to come. We've got things like self-driving cars that are on the horizon, and we've got Robert Scoble wearing crazy glasses that are coming. These kinds of things all run very advanced software inside, thousands of lines, tens of thousands of lines of code. They all create data constantly. This is big data, not Scoble, but just in general, big data. Big data at its best. Then there's this thing that they're starting to call smart machines. I was at a Google conference this week, and somebody was talking about smart machines, and what they mean is that the machines will start to answer questions for us, like a doctor would ask the machine, how do I diagnose this particular patient, or we'll ask Siri some complex question. And Gartner has this prediction that we won't even need humans by 2020. It will just be unnecessary at that point. Not quite, but you get the picture. It's headed in that direction where a lot of the intelligence is moving to systems. And the next leap beyond all this stuff I can't even tell you about it because it's somewhere in one of these guys' heads. It's somewhere in a guy that's working for a new startup, or maybe a guy that's not even out of high school yet. And the LAMP stack wasn't even created when that guy was born. He was born after the LAMP stack. It was kind of like, the era of LAMP hadn't even really taken root yet. So, I think that we're moving into a world that's just dramatically different than where we have come from, and it's super exciting. Another thing that I saw at that conference I just came from is there was a survey done. They asked who was the company that was going to lead the next wave. And they had all the usual suspects, Google and Apple and Facebook and Microsoft, but those weren't the ones that were at the top of the list. The top of the list was a company that doesn't even exist yet. They just said basically none of those guys have necessarily the idea yet. It's maybe a company like somebody in this room. So literally, I think it's a new world. And the common thread weaving its way through all this evolution that I've been talking about is that IT is now in the hands of the people. It's in the hands of the developers, the engineers, the architects, the people that are building the future. It's the first time in history that we're not looking to our vendor to give us the solution. We're looking internally. We're looking at ourselves. We're looking at our company and our customers, and we're looking for direction from internally. And we're not waiting for that roadmap from the vendor anymore. And this is actually how Rackspace ended up with OpenStack. We ended up having to build our own software. It was the first time in our history as a company that we actually built the product that we shipped to customers. Before that, it was things we bought off the shelf. It was servers and network gear, but we couldn't wait for the big virtualization guys to give us a cloud. We couldn't wait for that to happen. We had to go build it ourselves. So we built the underpinnings of our cloud, and that launched OpenStack eventually. Today, this is a picture of New York City. Today, everything is IT. Everything is, I'm actually reluctant to even call it IT. It's such a loaded term, but it's really connected. Everything is connected. That's probably a better way to describe it. Everything we buy, technology, products, services, gadgets, toys, whatever it is, industrial products, like I said, robots that build Teslas, whatever it is, it's connected. Even this badge is connected. I mean, it's crazy what, everything that we're doing nowadays. And so, Scoble he has a good term for that. He calls it the age of context, where you're really living in a world where computing is everywhere and it's embedded in everything. And I think that is the future. That's as close to the future as I can get you in terms of computing. I think that brings us up until now. So when you think about that, when you think about where we're at and where at least the crystal ball is taking us in the next few years, what is the future stack? What is the mythical future stack that's going to power all of that? Is it the LAMP stack? Is it the Windows stack? Is it Amazon's stack? Is it Microsoft's? Is it Google's? Is it the mean stack? Mean, you guys know what mean stack is? I heard about that one too, not too long ago. And all of these stacks that we thought were the future are really already in the past. As soon as we sort of identify and we observe something that we standardize on as a stack, it's kind of already too late. It's a concept that's difficult to sort of grasp, but I think of it like that Schrodinger's cat from physics class or chemistry where you observe it and it changes. I think that's like the stack today. I think we're in a world where it's changing so fast. So I would make the argument that there is no new stack. There is no future stack. What you need to be thinking about is really a new way of thinking about things, a new way of acting, a sort of a new philosophy for adopting technology, and expanding your concept of what this stack is to something beyond that traditional tech stack into something that is really a stack that would encompass your business and your culture and your environment that you live in at work. It's the people, it's the organization structure, it's the way you lay out a foundation for innovation, it's the way that you empower people with the new tools that they want to use. It's the APIs that you're going to expose to allow people to mix and mash up things. It's who you work with. Hopefully you work with somebody like Rackspace, but you got to find a great partner. You've got to work with somebody like New Relic. You've got to have people that are part of your ecosystem that make that possible. And centralized IT is not in control anymore. I know most little startups don't have an IT department, but you guys want to be big ones someday, so you don't want to get to the point where IT controls things. Businesses are breaking all the rules. They're reinventing everything from the ground up. The little guys, little startups are really in a great spot because they've already got this baked into their DNA. They're starting from a good place. They're way ahead of the curve. But a lot of bigger companies, bigger enterprises, even smaller businesses that are sort of a little older, they have a hard time changing their ways and allowing for some of this sort of uncertainty and the change. And I think they're still, honestly, mainly in a mode of, I'll buy something on-premise, I'll buy a software solution from a vendor that will solve our problem. Even the way they want to buy cloud sometimes looks that way. They think about, how can I put it in a box? And I think that's the wrong way to think about it. The startups, however, you guys and hopefully people that you represent, they're using really cool tools like Docker and Mongo and Redis, and they're exposing APIs, and they're building SDKs, and they're using Chef and Puppet and New Relic, and they're using all of these new awesome tools, and they're basically sort of turning that traditional idea of a stack sort of on its ear. It's not a stack anymore. It's kind of like a matrix that's always changing. It's always, I think about this like those little visualizations, clouds that you sometimes see where the words pop out and the one word tweet goes haywire and all of a sudden it gets to be a big blob, and things are changing constantly in that world. But there are certainly going to be some static elements. I didn't put the logo for Linux up there. I assume Linux is going to be there as a fairly consistent, but even Linux is getting sort of reinvented as we go. I have a friend that has started this company called CoreOS, which is sort of a new Linux foundation for the way we live in this new world of deploying large-scale applications. We see this kind of thing going on all over Rackspace. We have teams that are using every different combination of tools and languages that you can imagine. I think one of the key enablers to this is really open source. I sat in a session here Yesterday, they talked about how open source was where all the cool stuff was happening, where all the innovation was coming from. I also think open source is really, again, most of these products either are open source or they're tightly integrated with open source products, or they understand the open source community so well that they just get it. And I think the point is that open source is what allows these number of connections that are going to be made to happen. No single vendor can possibly keep up. They have to use the community. They have to reach out to their customer base. They have to have other people in community building with them to keep up. And I think that's really exciting. I mean, Docker is a great example. OpenStack's a great example. Two of the fastest growing projects I've ever seen in terms of open source. And they just keep coming. If you look at Hacker News on any given day, there's like a new project that shows up. This top one, I can't quite read it from here, but it's about MongoDB and how you're an idiot for using Mongo or how you're a genius. It's one or the other, right? It's like one way or the other every day. I saw another one the other day about using big data tools to solve little data problems and how the guy must be an idiot for doing that. Well, I say no. I say that really that's not the case. I say that you need to really choose the right technology for the right job, but you also need to try things. You need to try to use new technologies, whether they're perfect right now, they do teach you something. When you try new things, try new technologies like Hadoop for a little data problem, you're going to start to learn what's possible. You're going to start to learn what the future might look like for your product or your service or your company. You won't know unless you try. And that's actually one of the reasons I love the on-demand nature of the cloud and of SaaS and of products like, Rackspace has a few. We have Object Rocket, which is our Mongo service. We have Redis to go now. New Relic is a great example. All these products, you can spin them up, play with them. There's no huge investment required. You can get started very quickly. You can also get out quickly. Open source gives you the ability to get out. And that's what I love about building everything we do on open source. You're not stuck on any particular technology. You can take it elsewhere. I think open source and I think SaaS have radically reduced the friction to technology adoption, and that friction is what allows us to mix and remix these technologies at will. So my recommendation to you is to change your mindset, be agile, keep an open mind. You guys probably are already with me on this, but these are lessons for us to take back to our companies. These are lessons for us to use when we talk to our own customers. Have them keep an open mind. Think about things. Be ready for change. Be, accepting of uncertainty. I think those are all good lessons. We're doing that at Rackspace. We're running our cloud on our cloud. We're actually using our own tools to run the cloud. We're using what we call iNova, sometimes called cloud on cloud. We're using CI/CD to deploy our cloud. We're instrumenting our infrastructure with New Relic. We're running Hadoop and Cassandra. We're actually also turning all of that learning and expertise into services that we deliver to our customers. We have this thing at Rackspace called Fanatical Support, which for many years was sysadmins and DBAs and network engineers and storage engineers doing what those people do. And now all of that sort of turning toward DevOps and towards these new modern tools and toward developer-type interactions. We're actually hiring developers and DevOps people to be the future of what we think of as fanatical support. And we're bringing that expertise to our customers. I think one of the huge challenges with that crazy number of options that you have, look at this guy's screen, he's got tons of stuff on there. It used to be possible for one individual to keep the whole stack in their head. I remember having a guy that was good enough at MySQL and good enough at Linux and good enough at all the layers of the stack to really keep it all in his head. But it's hard to do that nowadays, especially with this constantly changing mix of technologies. And I would urge you to find your friends and your partners in the ecosystem, people that you can rely on. There's a few open source technology companies out there that I really like. There's a few SaaS companies. I love New Relic. I love Rackspace and some of the things that we're acquiring. We acquired this great company called Mailgun, which is a great tool for sending mail, and MongoDB. We have this Object Rocket, really cool technologies that you can take advantage of, and you don't have to be an expert at every layer of your stack all the time. I think having the DevOps guys and the engineers working, helping you with Redis and Mongo and Hadoop and Chef and Ansible and Salt and Jenkins and all these different tools that are in your stack. I think those are things that now you can hand off control and responsibility, and you can take responsibility and focus on the things that really, really matter. The other thing we've done at Rackspace is tried to be flexible in how we allow customers to deploy. This represents public cloud, private cloud, dedicated servers. We combine all of that into hybrid cloud, so we give customers the right tool for the right job. And again, we use all open source to make sure we don't lock people in. We want to make sure that predefined stack is end of the line at this point. So today, I think you have a choice. I think in the future, you'll have even more choice. You're going to have to figure out what really matters, what you want to focus on, what elements of the application stack you want to know better than anybody in the world. And you're going to have to learn to tap into the power of SaaS providers and cloud providers and the open source community to help you with the rest. And you can't and you shouldn't try to do it all yourself. The more heavy lifting you can offload onto somebody else, I think the better you're going to be. The faster you're going to go, the less friction you're going to have. You're going to have to embrace that change and that choice and embrace these massive shifts that are going on. You're going to have to get used to the idea that there is no more well-defined standardized stack and be okay with that uncertainty. And if you're not doing that, you're losing ground. I think you need to think about moving beyond that stack. And with every good ride to the future, you kind of come back to right where you started. So we're back at Disney. We're at the end of the journey where we started. I think my departing words is this is a journey and it's not a destination. We're just going to constantly be adopting new technology and changing. And to help you with that, Rackspace, we love developers. We've got a promo where you can get free cloud. These cards have been all over. You can go to developer.rackspace.com. You can sign up for free cloud services, and if you want to try New Relic at Rackspace, there's a 21-day trial on that. And I think with that, I would say to you that I'm done with all my prepared stuff, and I would be happy to take questions or take comments or anything you want to throw at me. Besides your badge, that thing would hurt if you threw that at me. I said the other day that this looks kind of like some kind of weapon where you could slice into somebody with that thing. It's pretty dangerous. Anybody have any thoughts? Anything I said resonate with you, or any questions in the room about what's going on? You guys ready for happy hour? Right here in the front.
What have you found to be the most challenging as you guys continue to grow?
The most challenging thing as we continue to grow has always been maintaining our company culture. We have a culture that supports fanatical support. We believe that it's very hard to be a great service company if you have a really crappy bunch of people that come to work grumpy every day and hate their job and hate their chair and hate their boss and hate their work environment. So we've tried to fix all that and put a nice foundation in terms of the place we work, in terms of the kinds of people we hire, in terms of the culture. But it's hard to maintain that without really focusing on it. And so that's another thing I would urge you guys to do. That is one of those things that should be very rock solid in your organization, is making sure your culture is strong, because that will allow you to embrace the change. That will allow you to have the right people on the team. You have to select people that fit your culture. You can't have that developer that's a genius, but nobody likes him and he can't work with anybody and he's a terrible person. It's just not healthy. And so I would say our culture is the hardest thing to sustain, but we've done it pretty well. We're at 5,500 employees now, and we're a big company now. But it's been a lot of fun, but it's hard work, and that actually has to be somebody's kind of job. It can't happen by accident.
Sorry, whose job is it?
Well, it starts with our CEO. He is chief fanatic, I would say. He's the guy that really comes to work every day and fires people up. He thinks about it a lot. Our chairman of the board thinks about it a lot. He hires people that he thinks are going to embed that into the culture and not tear that down. We've hired leaders over the years that have not been a good fit and didn't believe and didn't sort of buy into our culture. And they had to go eventually. They just had to, they weren't a fit. We had to get divorced. So I think the truth is, and that it really matters. In a small company, it matters. It mattered when we were 50 people. It mattered when we were 500. And it even matters more that we're 5,000 and we're spread all over the world. And I would encourage every one of you to think about that in your own company. Make it a fun place to come to work. Make it an engaging place where people are constantly learning. Make it a place where you can attract somebody that works at a competitor because they hate their job over there and they want to come to work with you. And it's not just about money, and it's not just about perks. I mean, we have good on all of those accounts, but we're not the best. We're not the highest paid, but we do attract great rackers, and they do love to stay, and they tell their friends to come on board. So I would say you can build that in your own culture, and that will sustain you through the good times and the bad times. Anybody else have anything? Any questions about OpenStack? Or yeah, there's one over there.
So with the rise of a lot of company offerings being SaaS and kind of trusting your data to a lot of companies, how do you think we avoid a world where companies kind of take that data hostage and prevent data portability, and kind of there's so much trust that you have to do when you use a lot of these services, and you lose complete control of your data
Right.
and kind of how you manage it. So if there could be a world where there are a lot of negative things as a result of that, so how do we kind of protect against that and make sure that a lot of these things that we use kind of are always in our best interest?
Well, one of the things that we think a lot about is, again, with open source as a backdrop of all the things that we're building. We think that's part of it, that we think it helps you with the portability of your application, with the ability for you to understand how your app would run at Rackspace versus somewhere else. So that's an element of it. There's also the trust factor of who you're working with. You've got to have somebody that you know, that you can be face-to-face with, that you have a relationship with, that you have a trust factor with, that you feel like is a stable company, that has a culture of transparency. It's one of our core values at Rackspace is full transparency. We say full transparency, no surprises. Really bad news first in every interaction with customers. If you don't have that kind of level of transparency, you really shouldn't trust somebody. If you can at least get a view behind the curtains and meet the CEO and understand who the people on the other side are, I think you can probably have a great deal of trust in those people. But that's something that you have to weigh on a case-by-case basis. So open source, and make sure your partners are good. And I think if you want to go beyond that, get your lawyers to write a good contract. I think that's the other thing that people sometimes do. I don't know if that really works. I mean, it doesn't always prevent bad things from happening, but it's something that at least you can sue them if you... Anybody else? There's one over here.
Hi, I have a question. So as a cloud computing company, you kind of own your customers' certain SLA, right? So how do you manage SLA versus introduction of new technologies in your stack?
Yeah.
How do you do this assessment whether new technology will be introduced in your system?
Yeah, so new technology versus an SLA, how do you balance that? Well, I think one of the things that we do is that we, again, are very clear with our customers that certain things are completely supported by Rackspace, so therefore completely under our promise of fanatical support on the SLA, and the other things that might come into the environment might be unsupported. I mean, we don't promise anything until we have fully staffed technology team, round the clock, all 3 shifts, capable of making sure that we deliver 100% on that. We won't put an SLA around it until we're 100% confident that we can deliver. So in the absence of that, customers are free to use whatever technology they want if it's compatible. And what we do is we just say that we'll do our best. We will promise you that we'll go as far as we possibly can. We'll use every possible vendor relationship or expert behind the scenes or whatever it is to take it as far as we possibly can. We don't stand behind we don't hide behind a contract or an SLA. We stand behind it, but we don't hide behind it. We want to make sure that we're just upfront and honest with you, but we'll take everything we can do possible to make it work, but we don't make promises beyond that. One last one I'll take, and then I have to go. I can just barely hear you, so let's wait for the microphone.
This question has to do with services in the cloud, wherein now you're trying to use the optimal use of the hardware. but now new hardwares come in that have special services that they can provide. So where do you see those fitting in so that you use optimal use of those?
I think I understand the question with clouds that don't have optimized hardware for specific kinds of applications. How do you blend? How do you take advantage of new hardware or new capabilities? Maybe it's GPUs or something like that. How do you take advantage of that? That's one of the things that we've really tried to address with our hybrid offering. You're setting me up for a sales pitch, and I don't mean to pitch you guys, but that is one of those things that that we've tried to do is just give you the flexibility to use the public cloud for what it's really good for. It's a general purpose platform. Everybody's public cloud is sort of general purpose. Obviously, there are some optimized capabilities that are around it. Our Mongo service is completely optimized for Mongo. So run your Mongo stuff there. On the other hand, we may not have a platform that solves something that you have a challenge with, and that's where a dedicated server might play a role, a server that's a physical bare metal machine sitting in a rack somewhere that we can customize with whatever RAM and storage and SSDs and whatever you need, and we can connect that side by side with the cloud so that you can kind of use both within the same context. And that's our definition of a hybrid cloud at Rackspace, is being able to mix and match those different form factors. So that's the way we've attacked it. I don't know if that's the only way, but it's certainly one that that seems to work for a lot of our customers. We have customers that have very specialized needs in certain industries. The guys that run online games are the most critical about their performance and their latency, and they need microsecond guarantees on latency. And those guys really do run just bare metal servers with very highly customized operating systems. Very unlikely that they would go to just a general purpose public cloud. So we run them next to one another. So that's it, guys. I appreciate your time. Thanks for staying. I think we've got... Thank you.